We're going to go down this very fascinating journey of finding zeros of polynomials, and we're going to start with not linear polynomials because those are so easy to find the zeros of, but we're going to start very basic here with just quadratic polynomials. And so, first of all, what is a quadratic polynomial? Well, quadratic just means the degree is 2. It has x squared, okay? So degree 2. And so these types of polynomials are pretty simple to find zeros of, and we'll kind of see why as we go through. We'll go through some examples here. Find the zeros. Find the zeros. Example 1, let's look at the quadratic polynomial x squared plus 5. And when we want to find the zeros of a polynomial, what we're trying to do is we're trying to solve the equation where that polynomial equals 0. And so if this were linear, like I said, it'd be so easy. Like if this was x plus 5 equals 0, you would just subtract 5 and be done. Now quadratic's not much worse, especially in this case. You notice that this quadratic, this x squared polynomial, does not have an x term. That makes it pretty simple to solve. So in this case, all we're going to do is subtract 5. So x squared equals negative 5. And then we're going to take the square root of both sides. Now, this is where it gets tricky. This is where most students mess up. And I mean from algebra through calculus and on. This is so easy to forget. Every number except for 0 has 2 square roots, a positive and a negative. So when you take the square root of both sides, you don't write x equals the square root of negative 5. You write x equals plus or minus. X could be the positive square root of negative 5, or x could be the negative square root of negative 5. Now, if you don't have familiarity with imaginary numbers or complex numbers, you may want to go watch some videos on those, specifically imaginary numbers in this case. So the square root of negative 5, however, is an imaginary number. So when you take this negative out of the square root, it becomes I times the square root of 5. So now we have that x is plus or minus I, the imaginary number I, times the square root of 5. So the zeros of this polynomial are the positive I times the square root of 5 and the negative I times the square root of 5. Those are the zeros of this guy. All right, so those are zeros of a quadratic polynomial. So zeros are important for many reasons. They can be useful in graphing. They can help you find intercepts, x-intercepts specifically. They can help you solve equations. They can also help you factor. So one thing that you can do from this is you can use these zeros and turn them into factors. I suppose I could show that really quickly. If you wanted to use these to factor x squared plus 5, well, you can turn zeros into factors simply by doing x minus each of these. So it'd be x minus I times the square root of 5 and x minus the negative square root of 5, I times the square root of 5, which turns into x plus I times the square root of 5. And so this simple quadratic polynomial factors like this using complex numbers, imaginary numbers, and that's because the zeros are imaginary. So that's one use for finding zeros. But in this video, again, I want to emphasize how to find the zeros. All right, let's do another example here. Example 2. And this guy is x squared. We want to find the zeros of x squared plus 3x minus 2. And so in this situation that's different from here, we did not have an x term over here. So when we want to solve this equation, right? When we want to solve this equation, we don't just have x squared and a constant. We've got this x that's kind of in our way. So that's a problem. However, The reason that quadratic zeros are about the easiest to find besides linear is because we have a very well-known formula to help us find the zeros. Now we don't have to use that quadratic formula when we don't have an x term. There's no need to overcomplicate it. If we don't have an x term, then we can simply get x by itself when we're done. If we do have an x term, the quickest, this is debatable. There are many ways to solve this type of equation. One is completing the square. I'm going to go the quadratic formula route because most people default to that because it works every time and it's something you can memorize and use over and over and over again. So I'm going to use the quadratic formula. Again, if you don't remember the quadratic formula, you might go review that. But in this case, you got your coefficients where a is 1, b is 3, and c is -2. So the quadratic formula tells us that the solutions to this equation, in other words, the zeros of the original polynomial are -b, so that's -3, plus or minus the square root of b squared, that's 9, minus 4 times a, which is 1, times c, which is -2. Let's use brackets here. Okay, so b squared minus 4ac, all over 2 times a, which is 1. So 2 times 1 is 2. And then it's just a matter of simplifying. That's where all the work comes in on the quadratic formula, is cleaning this up. So we've got -3 plus or minus the square root of 9 minus, and 4 times 1 times -2 is -8. And we've got one more step. 9 minus -8 is 9 plus 8. So the zeros are -3 plus or minus the square root of 17 over 2. So if I were to list those zeros, they would be -3 plus the square root of 17 over 2. And the other one would be -3 minus the square root of 17 over 2. Okay? All right, so here's a polynomial. It has, or a quadratic polynomial. It has 2 zeros. Over here, the zeros were complex. They had imaginary numbers. Here, the zeros have square roots, but no imaginary numbers. So these are what we call irrational zeros, right? Square roots that don't simplify are irrational. All right, let's do another example. Our third example. The third one, we want to find the zeros of 2x squared minus 9x plus 1. Again, we have this x term. And rather than writing the step where I set it equal to 0 now, I'm just going to go directly to the quadratic formula where a is 2, b is -9, c is 1. So the zeros are going to be -b, so that's +9, plus or minus the square root of b squared, that's +81, minus 4 times 2 times 1, that's the 4ac, all over 2 times a, so 2 times 2 is 4. So we have 9 plus or minus the square root. This is 81 minus 8, so that's 73. All over 4, okay? And those are the zeros. So we have 9 plus the square root of 73 over 4, and we have 9 minus the square root of 73 over 4. So again, in this case, we get 2 irrational zeros with no imaginary numbers, okay? So that's how to find the zeros of a quadratic polynomial. Pretty simple. Really simple if you don't have an x term, but if you do have an x term, also simple because you can always depend on this quadratic formula to help you out.